In this video, I will show you the graph of a simple cosecant function, y is equal to cosecant of x. This is the graph. You know what? This graph brings back some memories, difficult memories, and sometimes the memories I felt about my own mathematics education. When I was in high school, I didn't even know that there is a graph for your sine and cosine functions. I think the farthest we went in trigonometry when I was in high school was SOHCAHTOA. That's all. My high school education on trigonometry is SOHCAHTOA. Nothing else came after that. And so when I stepped into college and began studying your circular functions, I was kind of angry, really, and frustrated when I saw this. So how did this graph came about? There was nothing. Okay, there was nothing about the cosine and sine functions. Was there something about the sine and cosine functions that would help me understand this? That was the question I had to grapple with. And it turns out that indeed it was the sine function which helped me understand this graph. Okay, so let us bring back our unit circle and let us go back to how do we compute for cosecant? Well, given an angle whose angle measure is t, what we do is we pay attention to the terminal point of that arc. So it has a first and second coordinate. The second coordinate of that point is our sine of t. And so that is the first step to understanding cosecant of x, because the reciprocal of sine is your cosecant of x, or your cosecant function. Cosecant of x is equal to 1 over sine of x. So that was in fact the first step that helped me understand how and why the graph of our cosecant function came to be this way. This is what I did. I drew the graph of the sine function on the same rectangular coordinate system. And then I also drew the vertical asymptotes. Because obviously, cosecant function will be undefined when sine of x is equal to 0. So I have to draw my vertical asymptotes. And your sine function is equal to 0 when x is 0, pi, 2 pi, 3 pi, 4 pi, so on and so forth. Now, the next thing that I had to figure out, I am recalling my experience with the cosecant function when I was a student. The next thing that I had to figure out is why do we have a part of the graph that is above the x-axis and a part that is below the x-axis. So it is something to do with the sign. Is it positive or is it negative? So what do we know? Above the horizontal axis, your sine function is positive. Okay, so this one is from 0 to pi over 2 and pi over 2 to pi. The sine function is positive, so cosecant is going to be positive. So look at this. From 0 to pi over 2 and pi over 2 to pi, the graph is above the horizontal axis. So that's one thing. So that's one explanation about why this part of your graph is above the horizontal axis. How about this next part of the graph? Well, in the interval, okay, beginning from pi to 2 pi, the sine function is negative. The second coordinate of our terminal point is negative, and so when you get this, cosecant of x is also going to be negative. And so that explains to you why this part of the graph is below the horizontal axis. And so after one revolution, you are back to the first quadrant and the second quadrant. And again, the graph there of your cosecant is above the horizontal axis. So that part about the sine, okay, the sign of the sine function, positive or negative, helps me understand why you have a part of your cosecant function above the horizontal axis, you have a part that is below the horizontal axis, so on and so forth. The next part that I must figure out is the existence of the vertical asymptotes. I will no longer talk about it. Okay, so these are vertical asymptotes. And you know how graphs and curves behave in relation to the vertical asymptote. Okay, so I will stop there. Now, the next part is, why is this above the horizontal axis and why does it point upward? Okay, so the concavity is like it's pointing upward. And in here, your concavity points downward. Oh, why is that so? Well, guess what? It is the sine function which helped me figure out why that is so. So look at this. Cosecant of x is the reciprocal of sine of x. So what happens? So let's say, for example, x is pi over 2. So sine of pi over 2 is 1. And 1 over 1 is 1. Okay? So that is a part of the graph of your function cosecant of x. Now look at this. From pi over 2 to pi, your sine function is decreasing. It is decreasing. And so you know what's going to happen with your cosecant function if your sine function is decreasing. Cosecant of x is the reciprocal of sine of x. So if this part is decreasing, this part is going to be increasing. And the same goes with this one. Okay? So going from pi over 2 to 0, your sine function is decreasing. And so the cosecant function is going to increase. How about in this part? Let us go to the third and fourth quadrants. The sine function, sine of 3 pi over 2 is negative 1. So cosecant of 3 pi over 2 is 1 over negative 1. So it's also negative 1. Okay, so look at this. My sine function is increasing from 3 pi over 2 going to 2 pi. So what that means is my cosecant function, the reciprocal of sine, is going to be decreasing. This is increasing, and so this one must be decreasing. The same goes with this part. Going from 3 pi over 2, going back to pi, my sine function is increasing, and so my cosecant function is going to be decreasing. And so that's what I did. What I did first was I drew my sine function, the graph of my sine function, and then I traced the graph of my cosecant function. So that was how I was able to reconcile why the graph of y is equal to cosecant of x came to be this way. The key to my understanding, okay, I am recalling my memories of my education in trigonometry. The key to my understanding of the graph of y is equal to cosecant of x is the graph of the sine function.